page 21, you need to draw 2 circles. And I'm going to hold off on filling in the radii of 5 and 17 just for a moment. And let's go ahead and draw in the common external tangent first. So use the edge of your geometer to draw a nice straight line. We're drawing a tangent segment between the 2 circles. Mine didn't come out that great, but it's going to be all right. Now that I have the point of tangency, I can fill in my radii. So draw the centers of your circle, and now we'll draw the radii 5 and this radius 17. Draw 2 circles, draw the common external tangent, and now we filled in the radii. We learned yesterday that a radius drawn to the point of tangency is what? Who knows? Jamie? It is perpendicular, so let's go ahead and fill in these right angles. Now the problem asks for what is the distance between their centers. So I'm going to just fill in that distance. Oops, that didn't want to come out very well either. Oh well. And that's our x. That's what we're trying to figure out. Well, if you look on the bottom of the next page, there is a procedure table for doing these common tangents. And I know it's silly to put it on the bottom, so let's just flip down for the moment. Common tangent procedures. Number 1, draw the diagram. Well, we did that. Number 2, draw radii to the points of tangency. We did that already. It says label all the right angles and known distances. We did that. Step number 4, that's what we're about to do. From the center of the smaller circle, draw a segment that is parallel to the common tangent and extends to the other radius or its extension. From the smaller circle, from the center of the smaller circle, draw a segment that is parallel to the common external tangent. So this is the common external tangent, and I'm going to take from the smaller circle, which is this one, and I'm drawing a segment that's parallel. I'm saying that it's parallel. This is a procedure just for figuring these ones out. We're not proving it, we're just using this method to figure it out. Now if that is parallel, then that means that all these are right angles, even if they don't look like them. So, I can also fill in, I didn't fill in the length of my common external tangent. The problem gave us that the external tangent was 16. So if that's 16, then the segment I just drew in, isn't that also 16? Because I really just drew in a rectangle. Yeah, so now if this side over here is 5, then this side over here is going to be 5, which means how much is left over for that part? 12. Well, if this is a right angle, then that's a right angle, and now I see a triangle that I could fill in to get the distance between the centers. I'm going to do is I'm going to draw that triangle off to the side just to make it clear. We have this being 16, this is a right angle, and this is 12, and this is our x. That is a triple. Sammy? 20, yeah, because this is 4 times 4, 3 times 4, this would be 5 times 4, or 20. Any questions on how I filled that in?
How did you get 16?
16 and 16, the 16 was given in the problem as the length of the common external tangent, because we ended up drawing a rectangle. Opposite sides of a rectangle are congruent, so that side was 16 also. Basically, the triangle that it was given in the problem, Alan. I'm sorry. So then we ended up making this triangle here. And my triangle doesn't look like a right triangle because my original tangent lines weren't very good. And then I drew that up there. Alright? Okay, let's go ahead and go on to number 2. And I'm going to work this kind of slowly because I'm hoping that you can go ahead. The radii of 2 circles are 3 and 8. So go ahead and draw in the radii to the points of tangency. Try to work a little ahead of me. And the distance between their centers is 13. So this time we're trying to find the common external tangent. This one is 3. And this one is 8. We know that radii and are perpendicular to tangent lines. And let's see. We don't know that distance. Oh, we do know that. That distance is 13. Now that 13 is not just the distance in between the circles, that's that entire segment. So I could go like that. Now, if you need to look back at the procedures, go for it, but it's from the center of the smaller circle, draw a segment that's parallel to the common external tangent. Do that right now. From the smaller circle, draw something that's parallel, which would mean right angles here, here, and here. If the common external tangent is our x, opposite sides of a rectangle are congruent, that is x also. If this side of the rectangle is 3, then over here is 3. So this portion is how much? That's 5. I'm going to draw the triangle off to the side. There's our x, there's our 5, there's our 13. Yes, it's a triple. What is our x? 12. Questions? Problems? Concerns? Hopes? Dreams? Fears? All right, moving on. We're not going to do the ones that have common internal tangent. I figure I need a place to cut, and that's one type of problem I'm not going to be presenting. However, I could foresee far in the future on the Chapter 10 test that we'll take when we get back from spring break, which will be forever from now, I could foresee this being a bonus problem. So if far into the future you want to know how to do this, you follow the same steps, exactly the same step, but you can just end up having to extend one of the radii. So go ahead and try it far into the future, and if you want help, you can see me one-on-one for that. All right, let's do number 4, please. Circle O and circle P are externally tangent, meaning that they're just touching right here. Go ahead and fill in the radius for circle O and for circle P. We know that they're perpendicular, and we also know the steps, meaning from the center of the smaller circle, draw a segment that is parallel to the common external tangent. So we have that. And we don't know the length of the common external tangent, so that's what we're going to call our x. And that segment we just drew in will also be x. Well, this time we don't have the distance between the centers. Or do we? Let's see, if I draw this segment, and the circles are just touching. What is it, Jamie? You're right. This radius is still 18. That radius is still 8. When you add them together, because the circles are just touching, that will be the length of that hypotenuse. Now let's finish getting the sides of our rectangle. This is 8. So that means this segment is how much? How much was that last segment? 10. Billy, you're going to help me out. I'm drawing my triangle on this side. If this is our x, what can I put here? I'm talking about this triangle. 10, good. And then what am I going to put up for my hypotenuse? 18? It's going to be this whole distance. 18 plus 8? 26. Nice. Now, is this a triple?
Yes.
Natalie, what triple is this?
It's
Good. So what's our x going to be?
24.
Good. This is 5 times 2, 13 times 2, and 2 times 20, or 2 times 12. So that is 24. Nice job. All right. What I'd like you to do is we're going to skip number 5, but I'd like you to turn the page and start number 1. Number 1, and then we'll practice a walk around problem number 3. All right. Good job.